Hi students, how are you? I hope that you are all preparing well for your JEE MAINS examination. So, in your preparation, to help you for your preparation, I am explaining the chapter pair of straight lines last 2-3 days onwards. So, I am explaining the theoretical part of this pair of straight lines. In that, so let us see some more topics today. So, here the first topic is parallel and perpendicular lines. Now, first concept is the equation of the pair of lines passing through the origin and perpendicular to the pair of lines S is equal to 0. So, we know that S is equal to 0 means general form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So, those lines does not passes through origin. So, that means given a line, so for example, it is x axis and y axis is origin. There are two lines are there. So, let us take these two lines. So, this is equation of this line is S is equal to 0. Those are the two lines. Now, I want to find out the equation of the pair of lines which are perpendicular to these lines. Perpendicular to lines means what? So, see the first line is this is a line perpendicular to the first line and passing through the origin. And the second line is this, it is perpendicular to the second line and it is passing through the origin. So, these two are the lines which are perpendicular to the pair of lines S is equal to 0 and passing through the origin 0 comma 0. Then what is the equation of these lines is equal to given by bx square minus 2hxy plus ay square is equal to 0. Okay, now? So, very easy to learn. Okay, right. Coming to the second point, the equation to the pair of lines passing through x1, y1 and perpendicular to s is equal to 0. Here perpendicular to x is equal to 0 means what? Here the pair of lines they does not passes through origin. That means what? See here. So, this is a one pair of lines. So, this equation is s is equal to 0 and another set of lines are there which are perpendicular to this line. Perpendicular to this lines means what? So, this is a first line perpendicular to the given line and this is another line perpendicular. So, this is the point of intersection, that is x1 comma y1. So, this is a x1 comma y1. Now, if you want to find out the equation of these red lines, the formula is same, almost same, b, but in place of x, what will come? X minus x1, minus 2h, minus 2h, xy, in place of x, x minus x1 come, in place of y, y minus y1 will come. So, in place of y, y minus y1 will come. Same formula, that means in place of x1, y1, if you substitute 0 comma 0, in place of x1, y1, if you substitute 0 comma 0, you will get this equation. Substitute here 0, 0, 0, 0, you will get this form. Okay, now next we are going to see the parallel. Parallel means what? So, given the lines, so here the given these are the two lines given, S is equal to 0. So, these are the two lines. So, now there is a one line parallel to given line. This is another line and they passes through x1 comma y1. So, those are the two lines which are passes through x1 comma y1. Then what is the equation of the line? Almost also this is equal to ax square plus 2hxy plus by square is equal to 0 form. But here in place of x, what you will write? X minus x1. In place of y, what you will write? y minus y1. Okay, now? So, all these formulas are very similar to learn and easy to learn. Okay, now? I hope that you understand this concept. So, let us go for next concept. Welcome back to this concept. This concept is length of the intercepts. What is meant by length of the intercept? Let us see this. So, here it is x axis and y axis. Let us consider a pair of lines S is equal to 0 which intersects. So, this is S is equal to 0. S is equal to 0 means ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 unless otherwise stated. let these pair of lines intersects x-axis at A and y-axis at B. Then the length OA, this length OA is called x-intercept, and the length this OB is called y-intercept. So this is a x-intercept and y-intercept. So the x-intercept and y-intercept, the length is given by, so x-intercept given by the formula 2 root of g square minus AC by modulus of A. 2 root of g square minus AC by modulus of A. So the your y-intercept is given by the formula 2 root of f square minus BC by modulus of B. So this is the length of the x-intercept and it is length of the y-intercept. Okay, now right. So I hope that you understand this formula. Okay, so let us go for next concept. So the concept is here, if S is equal to 0 represents a pair of two lines, if the condition that these lines intersects x-axis is g square is equal to AC and 2FGH is equal to AF square plus BG square. G square is equal to AC and 2FGH is equal to AF square plus BG square. Second one is, if S is equal to 0 represents a pair of lines, if these lines are to intersect y-axis, if the lines to intersect y-axis, the condition is f square is equal to BC and 2FGH is equal to BG square plus CH square. So if these two conditions are satisfied, then the lines intersect y-axis. If these two conditions satisfies, those two lines intersects x-axis. Okay, na? Right. I hope that you understand this concept. Let us go for next concept. Welcome to this concept. So it is a pair of parallel lines. If S is equal to 0 represents a pair of parallel lines, to represent a pair of parallel lines, the condition is A by H is equal to H by B is equal to G by F. Otherwise, you can remember this, this is a well-known expression. So this is a H square is equal to AB and AF square is equal to BG square. That means if your equation of the line is AX square plus 2HXY plus BY square plus 2GX plus 2FY plus C is equal to 0. AX square plus 2HXY plus BY square plus 2GX plus 2FY plus C is equal to 0. If this pair of lines to represent a parallel lines, then the condition is H square is equal to A into B and another one is AF square is equal to BG square. Both the conditions should satisfy. If these conditions are satisfied, then these lines are parallel lines. Second one, once we got the parallel lines, again their question arises, then what is the distance between them? What is the distance between them? The distance between the parallel lines is given by 2 times root of g square minus AC upon A times A plus B, or 2 times f square root of f square minus BC by B into A plus B. Any one of the formula you can use, okay, na, to get the distance between the parallel lines. So this is a condition and it is the distance between the parallel lines. Okay, na? I hope that you understand this concept. So let us go for next problem. So welcome to this concept. So figures formed by given pair of lines. So the lines represented by H is equal to 0 and S is equal to 0. H is equal to 0 means you know that. So H is equal to 0 means AX square plus 2HXY. So H is equal to 0 means just AHX square 2HXY plus BY square is equal to 0. So it is a pair of lines passing through origin, and S is equal to 0 means AX square plus 2HXY plus BY square plus 2GX plus 2FY plus C is equal to 0. These are the pair of lines which does not passes through origin. So these are the two lines, and this also two lines, 2 plus 2, 4 lines. So with these 4 lines, there will be a there can form a quadrilateral. So if that quadrilateral is happens to be parallelogram. So, what is the condition on A, B, C, D? So, remember that here A, H, B, B value should be same. So, that is the main thing that you have to remember. So, why? Because if you observe all these parallelogram, rectangle, rhombus, square, the opposite sides are parallel. Opposite sides are parallel. Observe here all for all these 4 quadrilaterals. So, that is why if it is your ax square plus 2hx by by square, here also it should be ax square plus 2hx square plus by square. Then that external y term constant may be changed, right? If that quadrilateral happens to be parallelogram, the condition is a plus b is not equal to 0 and a minus b into fg plus h times f square minus g square is not equal to 0. Rectangle. Rectangle means what here? See here, adjacent sides are perpendicular. Adjacent sides are perpendicular. That means, so if these two represents SC is equal to 0, if these two represent HG is equal to 0. So, if these two lines are perpendicular, the condition is A plus B is equal to 0. See first here, for rectangle and square, the condition is A plus B is equal to 0, A plus B is equal to 0. Why? Because for a square and rectangle, the one of the angle is 90 degrees. That is why A plus B is equal to 0, A plus B is equal to 0. For parallelogram and rhombus, so those angle is not 90 degrees. So, you know that in parallelogram, so you will get, so it is not 90 degrees and it is a rhombus. So, this is also the angle between the adjacent sides is not 90 degrees. That is why A plus B not equal to 0, rhombus also A plus B not equal to 0. Okay, now. So, for rectangle A plus B is equal to 0, for square also A plus B is equal to 0. Now, coming to see that condition. For parallelogram and rectangle, A minus B Fg plus H times F square minus G square is not equal to 0. A minus B into Fg plus H times F square minus G square is not equal to 0. Okay. For rhombus and square, it is equal to 0. See here, if you observe here, so that is the equation of the, see here, diagonals you consider. So, this is the adjacent sides, that is diagonals. So, in a parallelogram and rectangle, diagonals are not perpendicular to each other. For parallelogram and rectangle, diagonals are not perpendicular to each other. That is why not equal to 0. Like that you can remember, not equal to 0, not equal to 0. But for rhombus and square, diagonals are perpendicular bisectors of each other. For square also, the diagonals are perpendicular bisectors of each other. Understand? So, perpendicular bisectors of each other. That is why is equal to 0 is equal to 0. Understand? Is equal to 0 is equal to 0. That is the thing. So, I hope that you understand these conditions. So, since the adjacent sides are not perpendicular, that is why A plus B is not equal to 0. Here also A plus B not equal to 0. Here rectangle for square, adjacent sides are perpendicular to each other. A plus B is equal to 0. That is why here also A plus B is equal to 0. That condition is about diagonals. Okay, now, right. I hope that you understand this concept. Let us go for next concept. Welcome to this concept. So, the concept is area of the figure formed by the pair of lines H is equal to 0 and S is equal to 0. So, always remember that the pair of lines represented by H is equal to 0 and S is equal to 0 are parallel to each other if you take the lines like this. So, this first pair of lines I am taking as ax square plus 2hxy plus by square is equal to 0. Second pair ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So, these are the pair of lines passing represented by h is equal. So, observe here. So, here ax square plus 2hxy plus by square. This is also ax square plus 2hxy plus by square. So, these are the pair of lines. The first thing is the lines, so this line is parallel to this line and these two lines are parallel. Then there forms a parallelogram. Otherwise, we cannot say maybe a parallelogram, maybe a rectangle, maybe rhombus, square, whatever may be that. That means opposite sides are parallel to each other. Opposite sides are parallel to each other. When these three terms are same in both the equations, then the area of the figure formed by these lines is given by modulus of C upon 2 root of h square minus AB. So, whether maybe it may be a parallelogram, maybe a rectangle, that depends upon the conditions already that we discussed. Then the area of the figure, whatever may be that, maybe parallelogram, maybe rectangle, maybe rhombus, maybe square, then the area is given by modulus of C by 2 root of h square minus AB. So, C is, we will take from here, h means in both the equations h is same, A and B also same. Okay, na? So, that is the formula to find out the area of the figure formed by the lines this and this. Okay, na? I hope that you understand this concept. So, let us go for next concept. Welcome to this concept, that is equations of the diagonals. Let us take the pair of lines S is equal to 0 and H is equal to 0. So, always I told that. So, here H is equal to 0 and S is equal to 0 are the separate pair of lines which are parallel to each other. So, parallel to each other, that means OA, BC. OA, BC is either opposite sides are parallel. OA is parallel to BC and AB is parallel to OC. Okay, now, right, they are parallel to, opposite sides are parallel to each other. That may be a parallelogram, maybe rectangle, maybe rhombus, maybe square, whatever may be that. So, if you want to find out the diagonal, equations of the diagonal. So, there are two diagonals obviously which will come. One is passing through the origin and another one is does not passes through the origin. Passing through the origin means what? So, here the h is equal to 0 is the equation of pair of lines passes through origin. Now, if you want to find out the equation of the line, equation of the diagonal passing through origin is simply S minus H is equal to 0. That means what? S means what? Equation of the x square, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c minus h. What is h? Ax square plus 2hxy plus by square is equal to 0. Obviously, those ax square plus 2hxy plus by square will get cancelled. So, what remain? A first degree equation in the variable x and y, that is 2gx plus 2fy plus c is equal to 0 will come. This is the equation of the line passing through the, which does not passes through the origin A and C. Right. If you want to find out the equation of the line, which, equation of the diagonal which passes through the origin, that is OB, if you want to find out, then the equation is given as GH minus AF into X is equal to HF minus BZ into Y. So, where did anywhere you saw this expression? As you have seen this, so what is the point of intersection? This is equal to HF minus BZ by AB minus H square, GH minus AF by AB minus H square. So, this is a point of intersection. So, this is a point of intersection. What is the equation of that line? So, y is equal to mx. Y is equal to mx. What is m? M means what? Slope of the line OB. Slope of the line means y2 minus y1 by x2 minus x1. y2 minus y1 means if you subtract, that is y by x will come. This ab minus h square, ab minus h square cancel. So, this is a gh minus af by hf minus bz into x. So, if you cross multiply, so see here hf minus bz into y, gh minus af into x, this only you will get. Okay. So, this is the equation of the pair of lines which passes through the origin. Okay, now, so this is the equation of the diagonal which passes through the origin. Okay, I hope that you understand this concept, that is equations of the diagonals. Let us see the next concept. Welcome to this concept that is called homogenization. So, this is a very important concept. So in parabola and conic section also, sometimes you come across this concept that is called homogenization. What is homogenization? Let us see. Let us take the equation of the curve. So this is a equation of the curve, sum ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Always remember that I am saying this the equation of the curve, not the pair of lines. They may be pair of lines, of course, they may be pair of lines, may be any curve. This is a any curve. So this equation represents a pair of lines depending upon the condition on A, H, B, G, F, C. Conditions is there. That is a delta is equal to ABC plus 2F, GHC minus AF square minus B square is equal to 0. H square greater than or equal to 0, G greater than, that conditions are. If that condition satisfies, then this equation represents a pair of straight lines. Otherwise, it simply represents a equation of a curve. Okay, now, right. So that is the equation of the curve. Let us take a straight line which intersects this curve at A and B. Let the equation of the line be ax plus my plus n is equal to 0. Now, I want to find out the equation of the pair of lines passing through origin, must and should. Equation of the pair of lines passing through origin, both the lines should pass through origin, and the point of intersection of the curve and the straight line. So this is the curve and it is the line, straight line. That means that we want to find out the equation of the pair of lines passing through the origin and the point of intersection of the curve and the line. As already in the previous classes, we know that equation of the pair of lines passing through origin is of the form ax square plus 2hxy plus by square is equal to 0. It is a homogeneous second degree equation in the variables x and y. What is homogeneous means what? See here, there are three terms here. What is the degree of the first term here? 2. What is the degree of the second term? 2. What is the degree of the third term? 2. 2, 2, 2. First term degree 2, second term degree 2, third term degree 2. Understand this? So, you have to get an equation of this form so that each term degree is 2. Okay. Now, coming to here, how to do this? But if you observe here, it is a general second degree equation. General second degree equation. So, you want to make it into homogeneous form. So, that means a degree 2. Observe here, the first term is degree 2, happy. The second term is degree 2, x, y, 1 plus 1, 2. The third term is degree 2, degree 2, degree 2, degree. So, we have to make these three terms also into degree 2. Okay, na? Then only we will get this format. That for that, how to do this? Take the first equation. See, first terms as it is. So this first term, since it is a degree 2, I am writing as it is. 2hxy as it is, degree 2. by square is also as it is, I am writing. Now 2gx. So I want one more x or one more y, so that I have to make it into a term of degree 2. First, for this, what I am going to do is Lx plus my is equal to minus n. So here Lx plus my upon minus n is equal to 1. Call it as first equation. So you call it as a first equation, you call it as. So now what we are going to do is, we are homogenizing. Homogenizing means what? We are making degree 2, we are making equal. Homo means same. Here degree 2, degree 2, degree 2, but here degree 1. Then how to make it into 2? Homogenization means 2gx into, in place of, call it as a put, can I put 1? No problem. In place of 1, multiply with Lx plus my upon minus n plus 2f into, already y is there, 2fy into 2gx plus 2fy into, in place of 1, let's substitute Lx plus my by minus n plus in place of c you multiply Lx plus My minus n whole square. Nothing wrong in it. Why? Because Lx plus My upon minus n value is 1. So, this value is 1, this value is 1, this value is also 1, 1 square 1. Now, observe here what is the degree of this whole expression. Is it homogeneous? Yes, it is a homogeneous. It is a homogeneous second degree equation. Why? So, this is a degree 2, degree 2, degree 2. 2g x into x square degree 2, x into y degree 2, y x degree 2, y into y square degree 2. So, Lx plus My whole square. So, if you expand this, x square you will get, y square you will get, xy term is also you will get. So, everywhere each and every term you have the degree 2. That is why this is called, this is a second degree homogeneous equation which passes through the origin. Definitely they will satisfy that condition, that is a delta is equal to 0, h square is not equal to ab, all those conditions it will satisfy. So, this process, that means making a general second degree equation into homogeneous, into a homogeneous second degree equation. So, this process is called homogenization. So, in the problems you will get how to find out the angle between them, showing that these two lines are perpendicular or coincides, all those things we will see in the future course. So, dear students, I hope that you enjoyed today's class, and tomorrow class onwards I am going to start the problematic part. So, I am going to discuss the problems which were given in the previous JEE mains examination. So, please watch my videos, and each and every topic I am explaining detailedly, and tomorrow's class surely I am going to explain all the previous JEE mains examination problems from the chapter pair of straight lines. Until then, all the best.